this presentation, we will be discussing the electric potential. So our learning objective for today is to know what is electric potential and what is the connection or relation with work, potential energy, and electric field. So before we start the discussion, I would like to introduce myself first. So I am Seshamir Esanon Versosa. Alongside with me in this discussion is Sofia Kimanyo, Neo Malinaw, Gian Mabansag, and Julian Vistacion. So now, let's start the discussion and know what is electric potential energy. Electric potential is essentially the amount of work needed to move a unit charge against an electric field. So it's a fundamental concept in the study of electricity. So the measurement of electric potential is closely related to electric field and potential energy. So just like how we measure the height of a hill before climbing, electric potential helps us understand the height or depth of an electric field. So it's like the electric height that a charge has to overcome or fall through. It is also important to note that the unit of electric potential is the volt, or denoted as big letter V. Now, let's dive into the formula for electric potential in more detail. So the formula of electric potential is given by V equals to W over Q, where V represents the electric potential in volts, and W represents the work done in joules, and Q represents the charge in coulombs. Here's a breakdown of the components of the formula. So electric potential is a scalar quantity that represents the electric potential per unit charge at a specific point in an electric field. So it tells us the amount of electric potential energy a unit positive charge would have at that point. So in the context of electric potential, work refers to the effort or energy required to move a charge against the electric field from one point to another without producing any acceleration. So it represents the energy transfer involved in the movement of charges. So charges or charge refers to the amount of electric charge possessed by an object. So in the formula, we consider the charge for which we want to calculate the electric potential.
The electric potential formula. So here is the example number 1. We will use the formula V is equal to work over charge. Let's substitute the values. V is equal to 20 joules over 5 charge. In order to calculate the answer, in order to calculate the electric potential, we will just have to divide the 20 joules into 5 charge. So therefore, the electric potential of this circuit is 4 volts. Let's consider another example to understand the formula better. Here is the example number 2. Since the charge is given as 2 coulombs and the voltage is given as 12 volts, we can substitute these values into the formula. V is equal to work over 2. To find the work done, we need to rearrange the formula and it will become work is equal to V times charge. Now, substituting the values V and the charge. Therefore, the electric potential in the circuit is 12 volts and the work done on the charges is 20 joules. Please note that this is just an example to illustrate the formula. In practical situations, the calculation of electrical potential may involve more complex circuits and considerations. So here is the example number 3. The formula for electric potential for point charges is V is equals to K times Q over R, where V is electric potential, K is Coulomb's constant. K is equals to 8.99 times 10 raised to the power of 9 is already a given. Q is the charge and R is the distance per charge. Now, let's calculate the electric potential. Q is equals to positive 4 microcoulomb, and it will become 4 times 10 raised to the power of negative 6 coulomb. The 10 raised to the power of negative 6 is already a given and microcoulomb, and the R is 3 meters. Substituting these values into the formula, V is equals to 8.99 times 10 raised to the power of 9 times 4 times 10 raised to the power of negative 6 over 3. The answer will become 3.99 times 10 raised to the power of 3 volts.
So now, let's dive into how electric potential is related to work, potential energy, and the electric field. So in physics, work is defined as the force that is applied to an object multiplied by the distance the object moves in the direction of the force. In the context of electric potential, the work done is the effort required to move a positive charge against the electric field from one point to another. This work done per unit charge is what we call electric potential. Since electric potential is defined as the work done per unit charge, in other words, it's the amount of the work done to move a unit positive charge from an infinite distance away to the specific point in the electric field. So, if you have a higher electric potential, it means that more work was done to move a charge to that position. Conversely, a lower electric potential means less work was done. This is why electric potential is often measured in volts, where 1 volt represents the work of 1 joule done to move a charge of 1 coulomb.
Now, let's talk about potential energy. Electric potential energy is the energy that a unit positive charge will have when it's placed in a particular position within an electric field. Is electric potential and electric potential energy the same? The answer is no. Electric potential and electric potential energy are related concepts, but they have distinct meanings. Because electric potential is like the measure of how much electric push or pull exists in a certain point in space. It tells us the amount of potential energy a charged object would have if it were placed at that point in an electric field. It's similar to how the height of a hill represents the potential energy of an object at that location. And electric potential energy is the stored energy that a charged object possesses due to its position in that electric field. It's the energy that a charged object has because of its location relative to its charges in the field. Just like a ball has a gravitational potential energy when it's raised above the ground, a charged object has electric potential energy when it's placed in an electric field. In similar terms, electric potential is like a measure of the electric push or pull at a point, while electric potential energy is the stored energy that a charged object has because of its position in that electric field.
Let's consider an example to illustrate the relationship between electric potential and electric potential energy. Let's say we have 2 points A and B in the electric field. The electric potential at point A is 10 volts and at point B is 5 volts. So imagine, we have a positive charge placed in an electric field created by another charged object. So the electric potential at a specific point in the field tell us the amount of electric potential energy per unit charge at that point. Now, let's calculate the electric potential energy at each point. So first, electric potential energy at point A. So assume that we bring a positive charge from infinity to point A. So the electric potential energy at point A can be calculated using the formula. Electric potential energy is equals to charge times 2 volts. So let's say the charge is 2 coulombs. So substituting the values into the formula, we get PE at A, or potential energy at A, is equals to 2 coulombs times to 10 volts. And now we get the total of 20 joules. So the electric potential energy at point A is 20 joules. Now let's move to electric potential energy at point B. So similarly, let's calculate the electric potential energy at point B. So assuming the same charge Q of 2 coulombs and using the electric potential of 5 volts at point B. So we have potential energy at B is equals to 2 coulomb times to 5 volts. So if we multiply the coulombs and 5 volts, we get 10 joules. So therefore, the electric potential energy at point B is 10 joules. So from this example, we can see that the electric potential energy depends on both the charge and the electric potential at a specific point in the field. A higher electric potential corresponds to a higher electric potential energy, while a lower electric potential corresponds to a lower electric potential energy.
Now, let's move on into the electric field. The electric field is a vector quantity that relates to the direction and magnitude of the force experienced by a positive test charge. The electric potential at a point in the field is the work done in bringing a unit positive charge from infinity to that point along an equipotential path. And now, we can relate electric potential and electric field by performing this formula, which is V equals to E multiplied by D, where V is the electric potential in volts, E is the electric field strength in volts per meter, or Vm, and D is the distance in meters over which the electric potential is measured. Let's go to an example to demonstrate the relationship between electric potential and electric field. Suppose we have an electric field with a strength of 200 volt Vm. We want to find the electric potential over a distance of 5 meters. Using the formula, we can calculate the electric potential as follows. So, V equals to E multiplied by D equals to V equals to 200 Vm multiplied by 5m is equals to V equals to 1000 volts. Therefore, the electric potential over a distance of 5 meters in an electric field with a strength of 200 Vm is 1000 volts. This formula shows that the electric potential is directly proportional to the electric field strength and the distance over which it is measured. A stronger electric field or a larger distance will result in a higher electric potential. That's all.